Hello, my fellow mathletes, and welcome back. We're looking at question 14 in this video from our 2016 Pascal. In the diagram, PQ is perpendicular to QR, QR is perpendicular to RS, and RS is perpendicular to ST. If PQ is 4, QR is 8, RS is 8, and ST is 3, then the distance from P to T, so this dashed line, is what? Okay. So let's draw our picture here. So we've got P to Q, Q down to R, over to S, and up by a bit to T. Okay. So how can we figure out this distance? Well, what I'm going to do here is, I notice all these little right angles. So what I'm going to do is I'm going to extend Q over to maybe this point U, which is the intersection of PQ extended and ST extended. And we can see we've got sort of a nice little rectangle brewing. Okay. Now, because it's a rectangle, SU is also 8, but ST is 3, so that forces us to have a 5 here, which I will clean up. So we have a 5 here. And this 8 here, well, it's got to also be the same as QU. PQ is 4, so in total we've got 12 up here. So what we're really looking at is PT is the hypotenuse of a right angle triangle that has side lengths, or legs, 5 and 12. So we could do 5 squared plus 12 squared is PT squared. And if you know your Pythagorean triples, and I do always encourage you to know the first few Pythagorean triples, you can just jump straight to 13. If not, well, you'll have to say, well, this squared is 5 squared plus 12 squared. And you might need to get out your calculator and figure out, oh, it's 25 plus 144, 169, and square root both sides. And you'll see that, yeah, PT is 13. But if you know 5, 12, 13, 8, 15, 17, 3, 4, 5, you know these Pythagorean triples, you can save just a little bit of time, and that adds up, especially as we're moving into harder and harder questions that might take more of our time. But our answer is going to be E, and so that's what we bubble in. And there we go. All right, so that was question 14, if I recall correct. Yeah, question 14. So we're going to be looking at question number 15, halfway through part B, in the next video.